Welcome to qnawire.
Hi everyone, so what we have is a shower head that has a volume flow rate of 13.3 liters per minute, and there's a new shower head that only uses 10.5 liters per minute of water. So what we're assuming is that each person takes a 5-minute shower, and then there are 4 people in this family, and we know the final temperature that the water is being heated to is 42 degrees Celsius, and we're asked to vary the input temperature from 10 to 20 degrees Celsius. And what we're asked to solve for is the energy savings as we vary that temperature between 10 and 20 degrees Celsius. So what we're going to do now is just go ahead and write down some pertinent information. We know that the density of water is 1 kilogram per liter. And we also know the specific heat of water is 4.18 kilojoules per kilogram degrees Celsius. So next what we're going to do is we're going to go ahead and calculate the volume flow rate that it saved. So what we can do is we can say that the volume flow rate saved will be equal to the original volume flow rate minus the new volume flow rate multiplied by the time it takes to shower for one person, and that's 5 minutes per person. And remember that we have 4 people, so there's 4 persons, and multiply this entire quantity by 365 days a year. And what this gives us is that we've saved the total volume flow rate equal to 20,440 liters per year. Now to translate this into a mass flow rate, we can simply take the volume flow rate and multiply it by the rho, and this gives us a total mass flow rate saved equal to 20,440 kg per year. Now what we can do is we can use this to calculate our energy saved, because we can say that the energy saved is going to be equal to the mass flow rate saved times C times the delta temperature. Now the delta temperature will be the final temperature to which the water is heated to, so TF minus our input temperature. Now remember, the input temperature is what we're changing to see how this affects the energy saved. So by changing this from 10 to 20 degrees C on this plot here, we can see the effect on the total energy that's saved. So on the x-axis we have the inlet temperature, which goes from 10 to 20 degrees Celsius. And on the y-axis we have the energy saved in kilowatt hours per year. So as you can see, as the inlet temperature goes up, we actually end up saving less kilowatt hours, and this shows a negative relationship between these two variables.